And we are going to kick it off. It is actually 10 after 7. I want to give you as much time as possible to play around. I want to keep you all the way till 8 o'clock because we're only working on one little task. I was going to try and mash a bunch of stuff together, but we're going to stick specifically to data types. But also, I want to spend a majority of the end of this lecture um, putting hands on keyboard. We're going to be kicking some code and we'll do it guided together. And I also want you guys to feel free to run off, do your own thing for a little bit, and report back and let the rest of your compatriots know how your experience was going. So we are talking about data types. Um, I know last week there was a bunch of people who could not make it to the lecture, and we were talking about data. Does anybody need a quick primer on data? Now we can get into data types. Are we good? Tell me yeah. If not, we'll run back. It's good.
I'm ready.
All right. Boom, we're doing it. Data types. My coffee, caffeine just kicked in. Buckle up. Ladies and gents, buckle up. Here we go. All right. So, tonight we will be talking about, obviously, data types, heavily foundation in what we were just talking about last week, which is what is data, and more importantly, how do we store data? We store data in variables. If you missed it, no big deal. We're going to do lots of practice tonight. We're going to talk about a couple of definitions for our data types, a brief intro. I want to get some hands on keyboard tonight, and I want you to start to understand why types exist in programming languages. We're going to get into all that, and we're going to spend some time declaring variables with different data types and seeing why some scenarios work better than others. If at any time you need to slow the bus or stop the train, let me know. But we're going to be doing a lot of guided coding. So when I say go, I want you guys to pull up a command line. You don't need to get into a crazy IDE. You can just get in a command line, and I'll show you actually. All you'll need to do is use the standard Python interpreter. So if you've installed Python from week 0, all you need to do is type in Python, and as soon as you see these three greater than symbols, you know you're in the Python interpreter. If it's getting a little too scary and you want to back out, all you need to do is do quit, open parentheses, close parentheses, and you're back out to the command line. So this is what I want you to be playing around with. We don't need to get heavy into an IDE. We're just going to be using basic Python interpreter, one or two line statements at most. All right. And we'll do it together the first couple times. So we're going to ease into this. No big deal. That being said, if you remember from last week, or if you pretended like you were here last week and you just heard my quick spiel, then you'll know that not all data is created equal. I consider there to be kind of an informational hierarchy. So let's say we have this disparate data and it means nothing to anybody. It's that digital stream of consciousness, that blah, like digital puke. And then I said, we put data together to give it some context, and then it becomes information. At that point, it becomes fully qualified information. But that's really not happens when data is interpreted by programming languages. Actually, what's happening is we're taking this data and we're casting it. We're basically assigning it a type, giving it some organization so that it can be read and stored properly. And this happens even before it becomes fully qualified information. We're going to spend the rest of this evening talking about why we do that, how we do that, and what the benefits of are for that. And I don't think you're going to find, new programming languages are cropping up all the time. Us seeing a programming language that does not associate a type with data is highly unlikely. I could see a lot of programming languages following suit like Python, which what we'll see here in a moment. So let's walk through this really quickly. An example of data, right? Disparate, just stuff that's out there, digital, blah, would be something like data A is 11. Doesn't mean anything. Data B is equal to Dave, right? Just a string of letters. Still doesn't mean anything to us. When we're typecasting it, when we're associating the type of data it is, then we're saying 11 is a number or an integer. Dave, those letters together are a string. It's a collection of letters or words. And that's what data types are. It's telling us what the data we're receiving, how it can be categorized at the most basic level. Types tell Python how to handle the data, what we can do with the data, and most importantly, especially when you're looking at larger programs, there's an inherent cost, right? And it's not monetary, but it's a cost for memory, for processing power. There's a cost to anything in the digital world. And types help a programming language, an interpreter, understand the cost of storing and handling the data. And that's what we're going to be talking about tonight. Any questions so far on any of this before we move into the next slide? Okay. To give you a little more outlay of the grounds that we're about to cover here, we can say data A is 11. It's an integer, or for short, it's an int, right? Python recognizes if it sees a number that I need to prepare this. We're using like informal terms here for mathematical memory. I'm going to be doing some kind of mathematical operation, or else why would you be giving me a number? You know, if I'm using a float, which is a decimal point number, versus an integer, which is a whole number, Python starts to make more space for floats because floats take up potentially much more room in memory with all of the decimal places and precision that are necessary than a whole number. So we're starting to see how Python, and it does this automatically as soon as you put in a value. It starts to make changes and make space within memory and the way it's going to handle the data so that it can most appropriately use it before you even know that you need to use it in a certain way. Last week we said that data that's stored in Python is dynamically typed. We're going to get into that in a little bit more, but can somebody give me a refresher what the idea of, or what the benefit of something being typed dynamically means?
I believe that means that it can be changed at any time.
Great. That's true. Yes. So the data, it's not locked into a variable. You store a value, it can be changed at any time. Also, another thing that makes Python fantastic, by the way, I really appreciate that. Um, Additionally, on top of that, we don't need to preface to Python what we're giving it. It's going to make some assumptions based on how we deliver data to it. So really quickly, we're going to get into some of these in more detail than others. I want to talk about some certain types. I'm going to highlight a couple of these for you. I'm not going to say that you need to slack on the ones I don't highlight, but you can slack on the ones I don't highlight. So I try to categorize these based on other resources that you might run across, and I think it makes a lot of sense when you think about it in terms like this. When you're storing things for programming purposes, the types are pretty consistent for most of the programming languages at the higher level here. When you get starting to the lower levels, well, actually Booleans are pretty universal, then things change. But there are types for text if you want to save your name or a sentence, but we don't call those characters or those words or text in program speak. we call those strings. It's a string of characters. So whenever you're in the programming world and you hear string, just think letters or numbers that aren't there for the purpose of mathematics. Can we agree that strings are words and letters? We got that? I know it sounds weird. Why can't we just call them letters and words? They're just strings. Now, on the flip side of that, if you do want to perform some math on something, you need to assign it a numeric type. But because it's programming and nothing is simple and straightforward, we don't call them numbers. We need to identify what kind of numbers they are. So just think whole numbers are integers, numbers with decimals are floats, and then imaginary numbers we'll call complex numbers. All right, so far we've got pretty much most of the language that we need to work with information. We got a type for words, sentences, letters, characters, symbols. Those are strings. We have a special type just for numbers, and that means, or at least precludes, that we can do mathematical calculations, we can do mathematical operations with these pieces of data. And then I'm going to skip down here, and there's one very unique data type. This harkens back to anybody who's taken electronics, any of the early electronics courses, and it's the concept of Boolean logic. That's like the original computing, was something is either off or on, yes or no, a 1 or a 0. In these regards, we're going to consider Boolean logic being true or false. All right. So really quickly, if I want to save my name into a variable, which type of data would I use?
A string.
Boom! Nailed it. Exactly. Perfect. If I wanted to save an age into a data type, which data type would I use?
Integer.
Perfect. Exactly right. And then let's say I want to get crazy, and I don't want to say what my age is. I want to say that I'm 37 and 2/3, but render that into a decimal. What would be an appropriate number type for that? I think I heard float. And if I heard float, you're absolutely right. Excellent, thank you. Now, let's say if I want to make a broad general statement and say like ESYST 131 is super cool, true or false. Where are we going with that one?
Sounds Boolean to me.
Totally sounds Boolean. Exactly right. Excellent. So you pretty much nailed it. I highlighted the things that I think are important. I made a mistake though. Forget about complex numbers. I'm not going to be doing imaginary numbers. Nobody's doing like extreme math science theory in here. Just worry or concern yourself with strings, ints. We won't even be using floats, but we need to know about them. And then we'll start talking about collections later. This one right here, dictionary, it sits in the collection group, but they're very unique, dictionaries are, so I put them on their own. This right here, lists, tuples, dictionaries, they're their own little funky jazz, and we're going to spend an entire week, maybe even 2, on collections and array types. That's how complex and in-depth, but also powerful they are. So really, initially, the only thing we're going to be worrying about is true or false, strings, ints, floats, and I think that's it. So if you guys can remember, strings are text, ints, floats are numbers, and booleans are true and false for the next quiz, which will probably be next week, then you're solid. You are absolutely golden. Any questions on any of that stuff or anything that you want to know? Just because they're here and we need to talk about them, binary types are very specific. Looking at, if you're not into like low-level programming, it doesn't mean anything to you, but what's called bitwise operation, like really working at a very finite, low-level set of information. That's where binary types come in. That's also what makes Python really powerful and could be usable at almost like the hardware level. Set types, sets and frozen sets, they call them immutable collections. They're collections that they're lists essentially, or organizations of data that all fit under one variable and they don't move. They're frozen. They're fixed. They're immutable. We're not going to be messing around with sets too much in this course. We'll do some edge case scenarios, but we'll spend most of our time in lists, tuples, and dictionaries. Cool. So if you got strings, ints, floats, and booleans, we are solid for the next couple weeks. I promise. Okay. Something else that you should know, we won't be talking about this, but when you're looking at these types in other languages, strings, ints, and floats and booleans in languages are called simple data sets, but they're more often known as primitives. The reason that they're called primitives is because everything else is complex. They're called objects. In Python, everything is an object, but we're so far from that right now. I just want you to be familiar if you're looking something up or Googling something and they're like, oh yeah, for primitives, these are the rules. Your strings, your ints, your booleans, and your floats, those are primitives. They're basic, very atomic versions of data. Oh, hey, look at me. I'm pointing out the stuff that I already told you about. Lastly, there are very, very special types for more complex things that we're going to be talking about later on in the class. I don't even want to make anybody's head spin, so we're just going to leave it at that. There's things called functions, which we might touch on, like barely like scathe at the end of this lecture. There's what are called objects and classes. Let's not worry about those for right now. Don't want to scare anybody away. Text, numbers, Boolean values. We should be good. All right. So let's get into some detail about the data types that we will be talking about. And much of this we've already hammered out. Strings, essentially text, right? Also known as primitive data types. You can know that a string is present because anytime you work with a string, you're putting quotes around it. I also want you to know when you're playing around in Python, you can use either single quotes or double quotes when you're talking about strings, but you got to be consistent. You can use from one line double quotes and then the next line single quotes, but if you're working within the same statement, starts with a double quote, ends in a double quote. Starts with a single quote, ends in a double quote, or ends in a single quote, excuse me. I now want you to get some practice. We're going to get hands on keyboards. Let's kick some code. And let's declare a variable with a string. I brought this up for you so you can see this from last lecture. Let me know, is anybody not able to actually access their command line right now? Okay. My assumption is everybody's able to access it. Let's start from scratch. If you're on Windows, you can just type in CMD, which is short for command line, in the start menu, and that will pull up this command prompt right here. If you're on Mac, what you're looking for is the terminal application. It's going to look slightly different, but it's just, in essence going to be the exact same thing. Let me know if you're having any trouble getting to this place right here, where you're saying a blinking cursor on a command prompt. Okay, are we all here?
Yep.
Yep.
Great, excellent. We're going to launch our Python interpreter. Going back to week 1, we call the Python interpreter the interpreter because Python is an interpreted language. It doesn't compile it. It literally goes down line by line to build out code. So we're going to start by typing in Python, And you'll know you're in the interpreter when you see these 3 chevrons, these 3 greater than symbols. If you're not able to see these by typing in Python, it's probably because you haven't installed Python from week 0. Hop on over to python.org, run through the install. The only thing you need to do is make sure that you've added it to your path, and then you can catch up with us and we'll be okay. All right. So I want everybody to create a variable of their choosing. I want them to use the assignment operator, aka the equal sign, and type in any string that they want. But you need to make sure you started with quotes, you ended with quotes. It could be single quotes or double quotes, your choice. Just remain consistent.
What did you put before what you make your string?
I'm sorry, say that one more time, Harley.
What was the thing you told us to type in again? The instructions for that, I guess from the beginning.
Oh, to get into the Python interpreter?
No, I'm there.
Okay.
What was the thing you said to do where we're gonna create a variable? You said create it as what?
Oh, anything that you want, as long as it follows the rules that we talked about. You can call it Jazz. You can call it Coolio. I'm gonna call mine. I'll go along with you guys. I'm gonna call mine a string with a capital
Okay.
S.
So it doesn't have to be like in the example below in the PowerPoint, like ASTR.
No. It can. This is unique. It's something that you want to call it that means something to you. As long as it doesn't start with a number and it has only letters, numbers, and underscores in it, you're solid.
And then the string that you're assigning has to be placed in quotations, right?
Exactly.
Okay.
So while you guys are doing this, I'm going to do mine. I'm going to call mine, my variable name is a string with a capital S. I'm using the equal sign saying I'm going to assign a string a value, and my value is going to be whatever's in quotes. Now, you'll know that you've done this correctly if after you've hit enter, nothing happens. I know that sounds weird, right? Usually problems only occur when the interpreter starts to complain to you.
Like syntax error type thing?
Exactly. That's usually what it's going to be. It's going to be saying, hey, something's gone wrong here. The cool thing about it, and we'll talk about this later when we see some errors, is the interpreter does a fairly decent job of letting you know where the start of your screw up was. It's like, hey, you effed up right here. It's really good for helping you figure out what's going on. So, after you've typed in your string and assigned it to the variable of your choosing, you can literally type in your variable by itself, and the interpreter will spit back exactly the value that you saved. Did anybody not get the exact value that they assigned to their variable? All right, I know it seems like we're doing baby steps here, but we're gonna be sprinting in no time. All right, so let's go back from the beginning and see exactly what happened. We picked out a name for a variable. A variable is like a tag for data, and basically we can say to Python, to the programming language, I want to tag this data with a name, and every time I give you this name in the future, give me this data back. We come up with our tag, we put an equal sign saying this is an assignment. We're assigning a value to this tag, and then you're putting in your value. When your value happens to be wrapped in single quotes or double quotes, Python says internally, I'm saving data as a string. I'm saving this as text. I want to treat this as text. I don't expect to do mathematical equations on it, and that's what it is. Sound good? All right.
Yep.
Cool. Like we're a quarter of the way to understanding all of the data types.
So if you close out the command prompt thing, I forget what it's called, the command window, command line
The
thing,
interpreter?
Yeah, will it remember these variables later, or do they only save them as long as you're in this session?
It's in the session. I don't know
Okay.
if you saw that. I just tried to type in my variable, and it's saying, um,
Okay, yeah, I did that same thing and it wouldn't recall it, so I was trying to figure out if I messed up or
no.
what.
When we get into saving our programs and saving data, we'll be able to save this. But right now, consider this all very temporary.
Okay.
All right. Excellent. Great question, by the way. Thank you. Okay, cool. So that's strings for you. Numbers, not all that different. The rules are pretty much the same for all of the number types, right? The integer, the floats, and the complex numbers. They're numeric representations. So when we do this, when we declare numbers, then Python assumes in some way, shape, or form we're going to be doing math with them. Or iterating, which means stepping through or increasing or decreasing. Something that it can do to manipulate numbers. Also a primitive data type. Numbers are never implemented with quotes or double quotes, because if we do, then it's going to assume, even though it's a number, you're not trying to do mathematical equations with them. It's going to assume that you're trying to create a string. I want you guys to do the exact same thing. Actually, give it one sec. We're going to kick some code here. Did I lose my command line? My command prompt? I totally did. I want you to go ahead, create two variables called age1 and age2, right? I want you to assign two different numbers to both of those ages. So let's say, for example, age1 is equal to 7. For age2, I want you to do a number, but I want you to surround that number in quotes. So example, age2 is equal to 14 in quotes. I want you to add age1 and age2 together. Regardless of your results, report back. Let's hear what you got.
Got an error.
You got an
It
error?
says unsupported operand types for int and string.
Okay. All right. Do me a favor. Let's hear, what was your age1 equal to?
10.
10. All right. Perfect. And what was your age2 equal to?
Quotes 23.
23. Excellent. All right. So let's go back. I'm going to type in age1 to the interpreter. I'm saying, here's the tag. Give me the information. It's like a coat check at a club. I don't know if they do that anymore. Do people do that anymore? Anyway. age1. Here's my ticket. What's the information you got back? All right, this is solid. We got back 10. Expected. I'm going to put in age2. What do you note about the return from age2?
Single quotes.
Yeah, it's unique. It's already been typecasted. It's already been assigned as a string. So if I try to do age1 plus age2, unsupported operand types, Python is telling you, I do not know how to add a string and a number and an integer. It just doesn't compute. And that's why we have to be mindful about how we're going to be using the data that we're putting into the system. If you want something to be spit back and used willy-nilly as part of a text, you're free to use a number. But if you're looking at incrementing the number, if you're looking at doing some kind of mathematical equations, if you're trying to manipulate it in any way that uses some form of mathematical operand, it's going to tell you it doesn't understand why. Does that make sense? I mean, it's a simple concept on the face of it, but if you think about it, it's kind of brilliant that Python can take something as simple as a symbol, like a single quote or double quote, and infer all this extra stuff about what you're telling it. We good on that?
Yep.
Okay, excellent. You would not believe how many pro programmers try to add a number to a string on a daily basis. It seems simple. Cool. I'm going to go through Boolean values pretty quickly. What you need to know is Boolean values mimic what transistors do, right? They read a voltage high or a voltage low, which equates to a 1 or a 0, and that's what the entire binary infrastructure is built off of, the presence or the absence of electricity. So that being said, a Boolean value represents true or false. Besides a few other edge cases, this is the one thing that you can add to, or you can assign to a variable that is text that doesn't have to be in quotes. And that's because the words true and false are considered keywords or specialty words or protected words, depending on what language you're coming from. So when you assign my bool or any variable to true, it's taking essentially the affirmative. Same is true with false. The reason this is so important is because you can do logic with true or false. A good example of that is if I'm trying to compare two things, one of them being true, like this variable right here, and one of them being false, and I ask, that's what two equal signs is saying, is this true or false? It will return false. That's like saying, is this equal to this? Is apple equal to orange? It's false. If this were apple and this were apple, the response would be true. And you can do the same thing with, right here. A_var, or a variable named A_var, is equal to Firefly. A variable named B_var is equal to Firefly. Is A_var equal to B_var? That's true. This is apples and apples. I want you to note here, we're going to spend an entire week talking about these operands, but the equal sign by itself is an assignment. Two equal signs is a comparison. So we'll get into that later, but I want you to see why that is. It looks funky if you've never seen it before. I don't want to jam too much on arrays and collections because we're going to spend a lot of time talking about them, but I wanted to at least make you familiar with it. We're going to go back and spend a little bit on collections each week before we actually get to collections, and then we're going to spend a lot of time in detail. One of the things that you need to know about collections is it's taking a lot of values and assigning it to a single variable. An example is item 1, item 2, item 3 is equal to a variable called list. While that might seem crazy, you're like, well, how does Python respond when you ask for a specific item within that list? There are different ways and syntax to handle that. But all you need to pull from this entire slide is there are different types of collections. They have different uses, but at the core, it's trying to save multiple values into one variable, whereas everything else we've been doing is assigning one value to one variable. Any questions on that? This is a little further than I wanted to go into it, but I wanted to make you aware of the existence of these things. All right, we're under the gun for time. I'm going to try to honor the time, but also make sure that we don't skip out on anything. If I need to do a follow-up video and post it, I definitely will. So let's talk about casting. Python is dynamically typed. It figures out exactly what you're trying to do to the best of its ability based on how you input it, and then allows you to re-add variables, values to specific variables. It makes a best effort guess based on the info you provided, right? So that's implicit. It's saying if there's quotes there, I'm assuming you mean a string. If it's a number and there's no quotes, I'm assuming you mean a number and you want to do math. You've got the power to go back and tell Python it's wrong and this is what I mean. And that's the difference between implicit and explicit. So for these list of variables right here, Python will implicitly say 12 is an int, bonjour is a string, false is a boolean, 11.7 is a float, and this collection of items are a list. We can control that. So we're going to skip this one. I move this one later on. I want you to take your command prompt, get that guy ready. I want you to add, this is going to sound crazy, 2 strings together. We got 5 minutes. I think we can get through this. I'd like to see you take a variable, whatever you want to call it, take another variable, add a completely different value to it, and then add these strings together, these 2 variables together. Tell me what you get. Because in theory, we shouldn't be able to add strings, right? We shouldn't be able to add text together.
It concatenated it.
Look at you. You got the terminology and everything. Exactly right. If I were to take string 1 and string 2 and add them together, Python says, all right, so I know these are strings. It's not meant to be math. You're trying to append these to each other, right? You're trying to make string 1, 2. Does that sound about right? That's crazy. All right, let's try something else. Does anybody have any questions on that? Because that's a really weird concept. I'd like to give you some practical reasoning on why this is used in programming languages. So the print function, this command right here, print open parentheses, close parentheses, is for saying like, being able to say something. But if you have multiple sources of information and you want to put into a function, which we'll talk about in weeks to come, or if you wanted to add these textual items together and give them context, that's where concatenation comes in. So for example, if I want to call a variable, we'll use avar again. So avar has class in it. I can print a variable by itself, information that I've stored for the purposes of exactly this, using it when I need to, and strings that I've done to create something unique on the fly. That's the reason concatenation exists. It's the ability to append data from different sources to make something unique because of it. Don't worry if this was flying over your head. I just want to explain that it doesn't seem logical that we should be able to add text together because text is not mathematically bound, but in programming we can. It's just basically smashing it together. It's appending one to the other or concatenating information. We are at time, and I was really hoping to do a code along with you. If you guys want to stick around for a couple minutes, we can do this, finish out this video. If not, no big deal. This video will show up on module 2 and you can follow along after the fact. It's completely up to you, but I do want to pause the recording really quickly and give time to answer any questions while you have me without wasting everybody's time, and then I'll continue the code along.